Okay. Tell me how you define Poisson process. I gave the definition now. Probability of, see the notes now. Probability of x of t equal to n is equal to, see the note, e power minus lambda t, lambda t about power n by n factorial. It is similar to the Poisson distribution. Instead of lambda, we are going to write as lambda into t. Okay. 20. So I think we stopped up to that one in the last class, right, Mama? Yes. Problem may be coming. We are not yet started, right? Properties of Poisson I given you. Did I stop? I told you to say put one more. I told you put the title. I asked you to refer to the book and study all the properties. Okay, now let's start with the problems. First one. If patients arrive at a clinic according to Poisson process, with mean rate of 2 per minute. Find the probability that during a 1 minute interval, comma, no patients arrive. Okay, so when you see in the statement normal dimension, that belongs to Poisson process. Normal dimension only. Okay, so what is the information given? We are discussing about the patients arriving in a clinic. They said that it is going to follow the pattern of Poisson process. So what is the average number of persons coming? Average number of persons? 2 per minute. In 1 minute, 2 persons are arriving. Okay. What is the doom of average is given? So what is the notation for average? We are following Poisson process, right? Which is called as the mean or average? Lambda. Okay, average means it indicates here lambda. So you are given lambda is equal to 2. Okay, what is the next one given? Find the probability that during a 1 minute interval. In which duration you are supposed to take? 1 minute. So you are given t equal to 1. Okay, comma, no patients arrive. So what will be the n value? No patients arrive. So what will be the n value? 0. So in our Poisson distribution we discussed x. X varies from 0, 1 to etc. up to infinity. Here we are going to make it as n. So all the information will be given directly, ma. Just have to substitute your formula and you will get the answer. Okay, so right. Let x of t be the number of patients arrive during a time interval. Given lambda equal to 2, t equal to 1. Lambda equal to 2, t equal to 1. So write next line. By definition, probability of x of t equal to n is equal to e power minus lambda t the whole power n by n factorial. This is the definition for Poisson process. Now you write what you are supposed to find. No patience arriving. What may interval. So what you are supposed to find? Probability of x of. What is the time interval given? 1. So x of 1, which is equal to how many patients? 0 patients. So this is how you must write your patient. The time interval what we are going to discuss and the number of processes or whatever data is given should be taken. Now substitute everything. You know everything. From this you can calculate lambda t. What is lambda t? 2 into 1. And be careful, everything should be of the same unit. Lambda equal to 2 per unit. Time t is also given as per unit. Both are given as the per unit. Be careful. Mostly the unit is the same one. Very rare they will change it. So now substitute everything. E power minus 2, 2 power 0 by 0 factorial. What is anything to the power of 0? 1. What is 0 factorial? 1. Find e power minus 2 in your calculator. 0.1. Still anyone without calculator? Yes, should we start the next one? Next problem. Next one. On the average, comma, a submarine on submarine, SUBMARINE, on patrol sites, patrol sites, 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 6 enemy ships, 6 enemy ship per hour, 6 enemy ship per hour, full stop. Then assuming that the number of ship sighted in a given length of time is a Poisson variate, comma, find the probability of sighting first subdivision 6 ship in the next half an hour. Second one, 4 ship in the next 2 hours. 4 ship in the next 2 hours. Third one, at least one ship in the next 15 minutes. At least one ship in the next 15 minutes. Fourth one, at least 2 20 minutes. Course shape in the next 20 minutes. So when you see the first problem, there was only one category. So we discussed it directly. But here what happens? Whether n and p varies for each one or not? Yes or no? So you are going to discuss each one separately because for each one n value as well as p value will vary. Okay? So start the solution. Write your definition. Write your definition you got first. Write your definition. Property of x of t equal to n is equal to e power minus lambda t the whole power n by n factorial. Any other information is given? Lambda. So how many shifts they are cycling on average? 6. We are given lambda equal to 6. This is common for general all the case. On average 6 shifts are cycling. Now study the first one. What is the first one you are supposed to find? 6 shifts in the next half an hour. Okay, half an hour means how you write? 1 by 2 per hour. Okay, if you want to convert everything in terms of minutes or convert everything in terms of hours, it's your choice. Okay, so what is the next one given? How many shifts you are going to cite? 6. We are given n equal to 6. Half an hour means t equal to 1 by 2 per hour. T equal to 1 by 2 per hour. Now substitute my everything is given directly. What are you supposed to find? Probability of x of 1 by 2 equal to 6. In half an hour you are going to cite 6 shifts. This is equal to. For this problem, only lambda t, lambda is 6, t is 1 by 2. What the answer? 3. Lambda is 6, t is 1 by 2. 6 by 2 will give you 3. So e power minus 3, 3 power 6 divided by 6 factorial. So using calculator you can get this answer. 0.0504. Tell me the second one. See the second one. How many shifts you are citing? 4. In how many hours? 2 hours. So for second one, what are the data given? N equal to 4, t equal to 2 hours. So what is lambda t? So lambda is 6, t is 2. So 6 into 2 will? What is the answer? What is lambda t value? 12. Lambda is 6, t equal to 2. So 12. So what are we going to find next? Probability of x of 2 is equal to 4. So e power minus 12, 12 power 4 by 4 factorial. Where it is?
It's in constant.
Constant. Have you identified? Shall we go for the third one? What is the third one given? At least one shape in the next 15 minutes. So what is the n value? 1. You should not say 1. What is that one? At least 1. Because 1 is different and at least 1 is different. What does 1 means? You write n equal to 1. At least 1 means greater than or equal to 1. Okay, அதை தப்பு பண்ணிட கூடாது. அதனால you write n as at least 1. If you write n equal to 1, what you will do? Even in the problem you will write equal to 1. Okay, so write n equal to at least 1. At least 1. What is the next one given? In the next 15 minutes. So what is the t value? 1 by 4. We will convert it as hour now because in the first two subdivisions they are taken t in terms of hour. Even though it is given as minutes, also you must convert it as hours. So 15 minutes means how many hours? Yes, 1 by 4. So t equal to 1 by 4. Find lambda t. So lambda is 6 and t is 1 by 4. So it is 3 by 2. What is 3 by 2? 1.5. Lambda t is 1.5. Now write probability of x of 1 by 4 at least 1. So what is the symbol? Greater than or equal to 1. So greater than or equal to 1, how many values are there? 1, 2, 6. Often it says 6. Approximately on average only 6 ships are there. Infinite. Poisson is an infinite one. It may be one shape or they may cite 100 shape or they may cite 2000 ships also. So we don't know what is the upper limit. So in that case, how do we solve the problem? Yes, what is the complementary? 1 minus probability of x of 1 by 4 strictly less than 1. Here you have included equal to, so here it should be strictly less than 1. Less than 1, what is the value of 0? 1 minus probability of x of 1 by 4 equal to 0. Now substitute your formula. 1 minus e power minus 1.5. 1.5 the whole power 0 by 0.5. E power minus lambda t. Lambda t the whole power n by n factorial. Here n value is 0. 0.7. Same answer. Complete it. Should we go for the next one? Should we go for the fourth one? So take down what is the fourth one given? At least 2 shape in the next 20 minutes. Again it is given to be at least. What is the time given? 20 minutes. 20 minutes in terms of power? 1 by 1 by 3. Okay, so We are given n as at least 2 and t equal to 1 by 2. What is the minutes given, ma? 20. To convert it our as 20 by 60. So you get it as 1 by 2. Okay. Now calculate what is lambda t. So lambda is 6 and t is 3. So that will become 2. Lambda t equal to 2. Again the same logic has been get here. So right, what is supposed to find? Probability of x of 1 by 3. Boys, what is supposed to find? Greater than or equal to 2. So greater than or equal to 2. Can you solve it directly? No. So what is the complementary? 1 minus probability of x of 1 by 3 less than
1.
less than 2. We can write less than 2 or you can write as less than or equal to 1. Anyway, if you put 2 means it should be strictly less than. If you are going to write 1 means it should be less than or equal to because 1 is inclusive. So this is equal to 1 minus probability of x of 1 by 3 equal to 0 plus probability of x of 1 by 3 equal to 1. Substitute the formula. 1 minus of lambda t value is 2. So e power minus 2, 2 power 0 by 0 factorial plus e power minus 2, 2 power 1 by 1 factorial. Find the answer. Others? That will be it. 0.59. 5939 or 5940. That is also acceptable. Any doubt, ma'am? Problems are difficult or easy? Easy, right? It's similar to our random variables. Okay, just you should be kept only in that unit. Either everything should be dealt with the minutes or all the entire problem should be discussed with hours. So according to that one, you change the conditions. Even the same problem can be dealt with t equal to minutes also. You convert everything in terms of minutes instead of hours. Shall I move on to the next one? Yes, completed. Boys, everyone completed? Take the next problem. Next one. A radioactive source. A radioactive source. A radioactive source emits particles at the rate of 6 per minute 6 per minute in a Poisson process. In a Poisson process. Full stop. Each emitted particle has a probability of 1 by 3 of being recorded. Find the probability that at least 5 particles are recorded in a 5-minute period. Okay, whether the question is clear or not? So what is the process going on here? The radioactive emits particles. Whether it is emitting the particles in a slow motion? Whether it is seeing the particles which is emitted? No. Okay, so what they are going to do here? The particles emitted are going to be recorded. Whether it is possible to record all the particles emitted? Possibilities irukuma? Irukadu. We may miss some particles because it is going to be emitted in a very fast way. Okay, so only here probability comes into play. So how many particles can be emitted? What is the chance of your particle to be registered? 1 by 2. எதனால இந்த probability கொடுத்துருக்காங்கறதுக்கான reason. Okay, இதுக்கு முன்னாடி previous problemsல வந்து just numerical data. Okay, அது fast slowல கிடையாது. Number of ships நம்மளால பார்க்க முடியும், number of patients coming in நம்மளால டைரக்ட்டா பார்க்க முடியும். So அங்க probability அவசியம் கிடையாது. But இங்க வந்து it is not visually possible. We can't collect all the information which is coming there. In that cases, we are going to take the help of the probability also to be included in our Poisson process. The same procedure of solving only, but a slight variation in our problem. So Poisson process without probability means you write the parameter as lambda t. If it is along with probability means you are going to write it as lambda into p into t. That's the variation. You are going to include the chance of an individual to happen also. Okay, so here you are going to write the parameter as lambda pt. That's the only difference. All the other procedure are same. Okay, so start the solution. Given, tell me what are given areas or given lambda 6. So right, given lambda equal to 6. What is the next information given? Probability. What is the probability value? 1 by 2. And what you are supposed to discuss? Find the probability that at least 5 particles are recorded in a 5-minute period. What is the 5 particles? Indicates which value? N. So you are given n equals to 5. For which time interval you are going to discuss? 5. So what is the t value? 5. So all the informations are given directly. Before starting with that one, find what is lambda pt. That is going to be the parameter that involves probability value. So lambda is 6, p is 1 by 3, t value is 5. Answer? Lambda pt is 10. Tell me how you proceed. How many particles are emitted? At least 5. At least 5 is what you are supposed to find. Probability of x of t greater than or equal to 5. At least means minimum. So greater than or equal to 5, what are the values possible? 5 to infinity. So how we must solve? 1 minus. So 1 minus probability of x of t less than or equal to 4. x of phi equal to 0 plus probability of x of phi equal to 1 plus probability of x of phi equal to 2 plus probability of x of phi equal to 3 plus probability of x of phi equal to 4. So what is the formula, ma? A power minus lambda pt, lambda pt the whole power n by n factorial. Instead of lambda 3, lambda p. Substitute. So 1 minus of first case n equal to 0. So e power minus 10, 10 power 0 by 0 factorial. Next one, e power minus 10, 10 power 1 by 1 factorial. E power minus 10, 10 square by 2 factorial. E power minus 10, 10 cube by 3 factorial. E power minus 10, 10 power 4 by 4 factorial. So you will get your answer as 0.97075. Instead of the variable as capital X, we can write it as capital N also. Okay, because here also numerical integer values we are going to discuss. So instead of writing it as x of t, even you can write it as capital N of t. Variables only. Okay, நம்ம right hand side மாத்தனால small n. Okay, அதே மாதிரி இங்க left hand side என்ன பண்ணலாம்னா you can write as capital N of t also. In some books they will be solving the problems with capital N notation instead of x. Get it? Others coming fast, I will give you the answer, copy down. It is written. Just copy the answer mark. Home you can check. Just one more problem. With that, you can stop at Poisson process. Should we start, mothers? Copy everyone. So next one is not actually a problem. You can say it as a property or you can say it as a theorem like that. Okay, we are going to prove it. So right, if sequence n1 of t. I hope you remember what is the sequence. If sequence n1 of t and sequence n2 of t. Actually, we will start from the random process. Okay, n1 of t and n2 of t is a process. Or two independent Poisson process or two independent Poisson process. If n1 of t and n2 of t are two independent Poisson process with parameter lambda 1 and lambda lambda 1 by lambda 1 plus lambda 2. Proof is lambda 2 by lambda 1 plus lambda 2. So we are going to prove it. So can you identify what is the right hand side answer? No? Binomial. Okay. So it is going to follow what process? If you combine it this way, it is going to follow the binomial process. That is what you are trying to prove to do. Okay. As usual, we are going to start with the basic definition. A given B. What is A given B? P of A intersection B by P of B. Just simply by using that conditional probability definition and Poisson process definition, we can come to this result. Okay. So start the solution or proof. Write it as proof. Proof. Start with your LHS. Write the given one. Start with the LHS. Write the given one. Left hand side. A given B. Is it everyone? Now tell me what is the definition? A intersection B by B. So write according to the definition from here. N1 of T equal to K intersection N1 of T plus N2 of T equal to N. They will write probability of N1 of T plus N2 of T equal to N. A intersection B by probability of B. Okay. So now what we are supposed to prove? We have to prove that it is going to become as a Poisson process. So look into the numerator. Denominator no problem. You know the formula. What is the definition of Poisson process? E power minus lambda t the whole power n by n factorial. Here n remains the same, but here is a summation of two processes. This is having the parameter as lambda 1 and this is having the parameter as lambda 2. So the overall parameter will become as lambda 1 plus lambda 2. This concept we have Poisson distribution discussed. 2 equal sum of two Poisson distribution will be again a Poisson distribution only with parameter as lambda 1 plus lambda 2. That logic. Sum of two Poisson process will be also a Poisson process with parameter as lambda 1 plus lambda 2. So addition of parameter in lambda lambda 1 plus lambda 2. So directly you can write it with that definition. But let us simplify the numerator. Why? Because in that it is an intersection. You can't apply the formula directly. When you can apply the formula, you are able to split them into different groups. Okay? இது தனியாவோ இதோட ஃபார்முலா எடுத்துக்கிட்டீங்க. இது தனியா வரும். இது தனியா வரும். அப்ப நம்மளோட ஃபார்முலா எடுத்துக்கிட்டீங்க இல்லையா? Yes or no? What will the parameter here? N1 now what is the parameter? Lambda. Instead of n value what we are having? If this is separate. If this is going to be separate, what will be the n value? N. What will be the parameter? into lambda 1 plus lambda 2 t the whole power n by n factorial. Anything will get cancelled off now? Whether the exponential will get cancelled off or not? It is e power minus lambda 1t, e power minus lambda 2t. Since the base is same, you can add the power. If you add the power, this will get cancelled with the exponential. So exponential term gets cancelled. Okay? The n factorial is denominator is denominator. So where it will come? Numerator. So it will be n factorial by k factorial into n minus k factorial. Combine all the factorial terms together. Next, see what is the answer you need now. Answer is very easy. What is the answer pattern you need? Lambda 1 by, what is p value? Lambda 1 by lambda 1 plus lambda 2. What is q value? Lambda 2 by lambda 1 plus lambda 2. According to that one, you will be able to see. Okay, bring the lambda 1 separately and also lambda 2 terms separately. Okay, so this final answer can be written as lambda 1 by lambda 1 plus lambda 2 the whole power k, lambda 2 by lambda 1 plus lambda 2 the whole power n minus k. We can change now. In this n can be written as n minus k plus k. So how can I write this n minus k plus k? The power of n minus k combined with lambda 2. The power of k combined with lambda 1. Then you can get the answer for it. What is the NCR formula? Combination. NCR formula. N factorial by or factorial into n minus r factorial. Instead of r, what you have it? K. So how will you write this one? NCK p power k q power n minus k. You can write what is p and what is q. That is answer what is supposed to be. A very simple result. So we already discussed what is the random process, then we discussed what is Poisson process now. The next one what we are going to discuss is called as the Markov process. M-A-R-K-O-V, Markov process. M-A-R-K-O-V, Markov process. It is the name of the mathematician who has found out this process, Markov. Okay. Simply if you want to say what is Markov process means, the future event depends only on the present status. It does not bother about the past one. Okay, that is called as the Markov process. So future la enna nadakka pogudu நம்ம கண்டுபிடிக்கணும்னா எனக்கு present ஓட information தெரிஞ்சா போதும். Okay, அதுக்கு முன்னாடி past la என்ன நடந்துக்கிறது எனக்கு தேவையில்லாதது. So that type of process only is called as the Markov process. So this is everywhere implemented in your speech processing, signal processing or in your image processing. Okay. So just an example means when you are going to speak, others has to understand the word what you are going to say. Okay, if they hear only the third word, you will know what, you will be able to understand what they have said. அது முன்னாடி என்ன சொன்னாங்க, அது முன்னாடி என்ன சொன்னாங்க, செகண்ட் வேர்டு நீ புரிஞ்சுக்கிட்டனா உனக்கு என்ன தெரியும், ஃபர்ஸ்ட் வேர்டு என்ன தெரியும். ஸோ ஃபர்ஸ்ட் செகண்ட் நீ கேளுங்க. அப்படின்னா தேர்ட் வேர்ட் புரியுறதுக்கு எந்த வேர்ட் உனக்கு போதும்? செகண்ட் ஒன் போதும். ஏன்னா ஆல்ரெடி 1 and 2 கம்பைன் பண்ணிட்டோம். ஓகேவா? ஸோ in all these ways to represent everything, the present information alone is enough. So in all those cases we take the help of our Markov process. Initially there is more theoretical part ma, கொஞ்சம் definitions எடுத்துக்கணும், கொஞ்சம் formulas எடுத்துக்கணும், theoretical தான் இருக்கும். After some time only we will go into the problems. Okay, so take down a random process x of t, a random process x of t is said to be Markov process, is said to be Markov process if probability of x of t less than or equal to x given x of t equal to x1, comma x of t2 equal to x2, this should be t1, x of t3 equal to x3, etc. x of tn equal to xn, x of tn equal to xn is equal to probability of x of t less than or equal to x given x of tn equal to xn. Can you understand the meaning? You are going to find the probability of x of t less than or equal to x. On the given condition is x1 completed, x2 completed, x3 completed, up to xn is completed. Up to xn everything is completed. Based on that we will find less than or equal to x. So able to understand this instead of assuming as n plus 1. Okay, we are going to find the chance of n plus 1 equal to half. What are the events have already completed? x1, x2, etc. up to xn. Everything is completed. Based on that one, we are going to find n plus 1. For that, which information alone is enough for us? Only what happened in xn. I don't bother what happened in x1 or what happened in x2 or x3. That doesn't matter. Which is alone is enough for you? If you know what has happened in the previous one, just on xn alone. That is enough for me to identify what happened in n plus 1. This concept is called as the Poisson process. Okay, so right, that is if the future value depends only on the present state, depends only on the present state, but not on the past state, is called a Markov process. It's called a Markov process. So make a note. x1, x2, etc. xn, x1, x2, etc. xn are the states of the process. In the state, states of the process. So, engineering frequent apply பண்ண நிறைய cases இருக்கு. As I told you, very image process, signal or speech recognition, everywhere is applied. Day-to-day life normal thing is weather prediction. To identify the weather prediction, how many days data they will transfer? Past 1 year. நான் என்ன நடக்க போகுதுன்னு தெரியும். process. According to T is discrete or continuous. Here also the same classification. Similar classification. First one, continuous random process. Continuous random process satisfying Markov property. Satisfying Markov property is known as continuous parameter Markov process. Continuous parameter Markov process. That is both x and t suffix I. X and t suffix I are continuous. When we make continuous, then it becomes a process. Both x and t suffix I are continuous. Then it is called as the continuous parameter Markov process. X and ti are continuous. Second one, T discrete. I am telling you in short. T discrete and xi continuous. T discrete and x continuous. X suffix I continuous. This is called as discrete parameter Markov process. Discrete parameter Markov process. Third one, both the t and xi discrete. Both t and xi discrete. This is called as discrete parameter Markov chain. Discrete parameter Markov chain. Fourth one, T continuous. Fourth one, T continuous and xi discrete. T continuous and xi discrete. It is called as continuous parameter Markov chain. Continuous parameter Markov chain. X continuous you say it as process form. If x is discrete means you say it as chain. So total is divided into 4 categories according to the nature of x and ti. In this we are going to discuss only one concept now, the case of discrete. That is the Markov chain concept what we are going to discuss now. Okay, நம்ம நாளைக்குமே டிஸ்கஸ் பண்ண போறதில்ல. We are going to concentrate only on that discrete case. So what is the meaning? Discrete parameter Markov chain is discrete. Both t as well as xi. Both are discrete. So ரெண்டுமே discrete இருக்கும்போதுங்கற கான்செப்ட் மட்டும் தான் நம்ம டிஸ்கஸ் பண்ண போறோம். We are not going to discuss the remaining three concepts. Okay, take your next topic. Discrete parameter. 10 more minutes now. Discrete parameter Markov chain. Discrete parameter Markov chain. Okay, actually Markov process definition கொடுக்கும்போது நமக்கு எப்படி எழுதணும்? X of t less than or equal to x. எல்லாமே x ல denote பண்ணும். And it may be continuous or it may be discrete also. But நமக்கு இங்க என்ன ஆக போகுது? Everything is going to be only discrete. So we are going to write it with equal to and number notations. That's the difference. Okay, so write if probability of definition. If probability of xn is equal to a, since it is discrete, we are going to write like this. All are going to assume only discrete values. Xn equal to a when given xn minus 1 equal to a n minus 1, xn minus 2 equal to a n minus 2, etc. out. This should be equal to what? Now you tell me. You know what is Markov process. This should be equal to what? Log area of xn equal to an given x not என்னக்கு முன்னாடி வேலை இருக்கும் n minus 1 given x n minus 1 equal to a n minus 1. x naught is the starting place. நான் இங்கிருந்தா அங்கிருந்து நம்ம அண்டர்ஸ்டாண்ட் பண்ணணும். ஓகே என்னோட previous value என்ன? என்னோட previous value n minus 1. Okay, so the current future is going to depend only on the current state. Put a command right for all n. For all n. For all n. Then the process xn equal to xn comma n equal to 0 1 2 etc. xn n equal to 0 1 2 etc. is called a Markov chain. Is called a Markov chain. Full stop. A1 A2 etc. an A1 A2 etc. to an are called the states of a Markov chain. Are called the states of a Markov chain. Are called the states of a Markov chain. So how we will be discussing the problems and understanding is that initially it is going to be at x0, to which place it is going to reach xn. It is not going to go directly. How it is going to go? From x0 to x1, then x1 to x2. Okay, etc. It goes to xn minus 1. Then from xn minus 1 it is going to go for x3. So the a1, a2, etc. to an are called as the states. So in the state those notations are very important to apply the formula. Okay. Take down one more definition. The conditional probability of xn equal to aj given xn minus 1 equal to ai. xn equal to aj given xn minus 1 equal to ai is called the one step transition probability from state ai to aj, from state ai to aj at the end state and is denoted by Pij of n minus 1 comma n. Pij of n minus 1 to n. So the notation should apply now. It is in state I, it is moving to state j from n minus 1 is stretched to n plus 2. Okay, if we use a further form of notation also, it will get the applying this. Okay, what is the meaning? From state I you are moving to state j. Okay, from which step to which step you are going to go? You are ordering n minus 1. From that you are going to go for n. That is the meaning of this. So what is the other way you can say is that I gave you the word as transition probability, that is called as the TPM. Okay, number of steps. So in which step you are n minus 1. So which step you are going to move? Yeah. So how many steps will be taken? Only one. So that will be the. Okay. In case it is n minus 2 to n. How many steps you will be moving? 2. N minus 2 to n minus 1. Then n minus 1 to n. So that relation will be given as. Okay. Now general discuss from regular steps set will go. Other which you can write this. Okay. Let's stop up to this one now. Next class I will